Hello everyone, how's everyone doing today? Alrighty, second day of the advent of code, so let's get straight to it, alright? Again, we're dealing with SurrealDB instead of any other programming language. We already did it yesterday, so let's look at today. We'll see if we'll be able to do just this one puzzle in two parts, or we'll be able to actually do a little bit of next day, which will be fun. Because I'm one day behind. All right, day 2, gift shop. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole, gleefully explains a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here. And from there, you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks you for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product IDs ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, okay, 11 to 22, 95 to 115, 998 to whatnot, and even larger numbers. Okay. All right. The ID ranges are wrapped here for legibility. In your input, they appear as a single long line. All right. So we'll need to just split by a comma. All right. The ranges are separated by commas. Each range gives its first ID and the last ID separated by a dash. Since the young elf was just doodling silly patterns, you can find the invalid IDs by looking for an ID which is made only of some sequence of digits repeated twice. So 55 is 5 twice, 6464 is 64 twice, and 123 is 123 twice. Would all be invalid IDs. Oh. So 11 to 22. This one will be valid. This one is also valid. This is not really repeated. And yeah, this one's correct. This one's correct. Yep. 446 and 443, so this one is correct. I'm just checking this input to make sure everything is all right. This ends with 21. This one is again unique. None of the numbers have leading zeros. Okay. So 0101 isn't an ID at all. 101 is a valid ID that you would ignore. So that simplifies a lot. Your job is to find all of the invalid IDs that appear in a given ranges in the example above. Oh. So, wait a moment. I was doing the patterns. You can find invalid IDs by looking for an ID which is made only of some sequence of digits repeated twice. Okay, so everything that has anything repeated. Okay. So, yep. 11 and 22. That's right. Oh, so if a range has an invalid ID inside of it. Oh, 95 to 111 has one invalid ID, 99. Oh, wow. Okay, this is... At least those ranges aren't like massive, right? Okay, has one invalid ID. This thing. Okay, so basically we'll need to generate all the numbers from here to here and check them. Basically find those specific ID. Adding up all the invalid IDs in this example produces this much. What do you get if you add up all the invalid IDs? And there's the puzzle input. Okay. Okay, this is gonna be interesting. So we can get our puzzle input, and that's it. So we can just grab it. I'll copy it. And what we can do is we can just copy this file and say this will be day 2, part 1. Okay. And instead of doing this whole thing, we're going to select from here to all the way, here, right? And going to paste over and we're going to finish it here. All right. So yeah, this should be the input for creating the thing. So let's copy it, plop it here. So this will be our correct input. Okay. Let's just double make sure we can run the query and we have it here. Explore, temporary, and there we go. Okay, great. So we have our input. But how do we process it now? So my thinking here would be that we would basically need to take the first, let's take this as an example. We would need to generate something that's repeating the first, something. We would need to check something that I guess that's the same length. They all suggest that it will be the same length. Let me just inspect the data again. No, look at that. This one has also different lengths. Okay. If this is length 3, this is length 4. Oh, no, we need to look for all the possibilities inside of that will be repeating. Oh, like all the possible possibilities. It doesn't have to be here at all, just all the repeating weird stuff. Not good. This is a lot of brute force. But at the same time, we don't have that many examples. So let's grab something like this. We have 6 digits here, 7 digits here. Let's grab this as an example and kind of try to work it out. All right. Let's just put it here and we'll just paste this here. The most naive thing will be that, okay, we're grabbing the character 1, the digit 1, and we repeat it until we have the same amount of characters. All right. And we can see that, oh, this is out of range. So now we're going to grab another one and another one. And this will generate few possibilities, okay? All the way to until we hit actually this one. And this one will be the first one that will be, oh, this says within range. And yes, repeats. Yes, in range. And that's our first one that we found. So after that, we need to start generating, oh, wow, this is going to be endless number of things. because let's say that we decide on 10, right? We generated this one, and this one is no. And then we just do what? 11 and 12. We will go all the way to 19 and still not fit. Then we'll be going from whatever, from 20 to 29. And all the way to really until we hit 96. This is the only time when we will actually get something. And that's just for that length. What if we want to go with a different length, like with this one? We could, in theory, do this one. Add one more. I mean, that wouldn't be repeating though. So won't matter, but yeah, in theory, if this was a little bit larger number, this could fit in there. Ay, ay, ay. So we need to kind of think ahead of what are the possibilities of actually doing something here. So maybe instead of just doing it completely blindly, because by the second character, we already have so many options. Then we have 3 characters, that will be hundreds of options or thousands, and it just multiplies into unmanageable thing just for the simple number, while we have something vastly larger here at the, as a possibility. So I would scrap this completely. And maybe we should move on to something where instead of just picking a random number, we kind of process first all the possibilities that are larger than the number on the left, and then ones that are smaller than one on the right. Okay? And we could do it in a way that, hey, how about we start with the character that we already have, the character 9, right? And we just generate one that's repeating. Okay, and then is it within range? Yes. Therefore, is it like, fully in range? Yes. And we have our first hit. Then as we go into double digits, we need to start with a number that's the 2 first characters, 96. Okay? And that will be already in range, so we can do 96 and 96. And that will be yes. And that means we also need to go with 97. Okay, so we basically could generate the first 2 characters and check if they are within. Okay, I see. So we generate numbers that are all the numbers that are from, let's say if we're at the 2 characters, so are within 96 to 101. So if the second number is 1 character longer, we need to kind of restrict it to less or equal 101. Okay. So this will be gen numbers from 96 to 101 and try for all of them. So that will be it. Then if we wanted to go for one more thing would be, hey, we're doing a triple digits now. So it'll be 967. So it'll be 2-digit. Okay. Then it will be 3-digit. So we from 967 to 1012 plus 1. Okay. We want to just do the plus 1. Or like, I mean, we can go larger. We just want to have it within range. Yeah, something like that. But that already generates, like, leaves a lot of room, right? That is gonna be a lot of combinations, and the number of them will be just increasing. For every iteration. So additionally, we need to, because let's say for 4-digit, it will be 9676 to 0129. And that's already thousands of combinations to try. So at that point, we would basically need to check if we even can divide those lengths of number of characters by the specific number. So in this case, we have 6 character to 7 character. That's our range here. Okay. So in that case, all right, so we basically need to see if we can generate a number that is within that range. That's gonna create numbers within that range. So let's say 1-digit, of course, it will work. For a 2-digit, they will fit here, but they won't fit here at all. So this is where we can straight up cap it at 99. So cap at 99. All right. Okay. That could work. Then here, 3 digits. For the 6 will work, for the 7 won't. So again, we'll add cap at 999. And for 4-digit, we just can't, because none of those will actually contain 4 digits. So nope. 5-digit, nope. 6-digit, yes. But it's already a length of the first range, so it won't work. So it will be, nope. Reached max. But the question is, do we have range that is like, because technically we could have a range that would go from something like from 20 to something of this sort, right? 1, 2, 3, 4, 5, 6, 7, 8. As in we have more than 1-digit difference. What then? Because this whole thing suddenly falls apart. Because that means we have more checks. But do we have a situation like that? We have 3 and 3. We have 6 and 7. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. This is 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is again 10. So that's good. 5 and 6. Okay. 7 and 7. Yeah, I'm just gonna like check all of them, because this is 7. This is 7. Good. This is 6 and 6. 8 and 8. We have 6 and 6. This is again 6 and 6. 4, 4, 6, 6, 2, 2, 2, 3. And what about this one? This is 10 digits versus 10 digits. Okay. 9 digits and 9 digits. Okay. 5 and 5, 3, 3, 4, 4, 1, 2. Just a few more to check. 9 and 9. 7 and 7. 10 and 10. Yep, 2, 2. 5, 5. Again, 10 digit versus 10 digit. Alrighty. This looks okay. This looks okay. This one looks okay. I'm starting to be able to compare it visually, yeah. And hello, Anonymous 41. Oh, I'm not streaming text editor. Thank you so much. Sometimes I make those silly mistakes. Yeah, I'm comparing the lengths to see if we have any disparity in like larger than 2 digits in length in the range, because that affects the algorithm, how complex it needs to be. So far, so good. No traps here. Wait, this one is 5 and 5, so this is 10. 5 and 5, this is 10. Awesome. 3 and 3. Come on. 8 and 8, we're nearly done. 8 and 8. Then we've got 6 and 6, and here we have 4 and 5. Okay, so we don't have any larger disparity larger than this, what is it? 1 character. So that means that this algorithm will work, where if we get to the length limit of a single character, we don't need to try it. The only difference would be single digit characters. But then we have a situation where, yeah, we should do that, yeah. I mean, the only, like, there was a nice example of it being 1, 1 to 2, 2, right? So let's say if we change it to range from 11 to 23, right? I'm gonna move it down. So we have 11 to 23. We need to, I know that those will be 11, 22, and that's pretty much it. That's all that we're gonna find as repeating. And Anonymous is asking, what techniques are you baking? So right now, I have a technique where we basically grab a kind of first digit here and repeat it that many times as possible. Is it in range? No. Or yes or no, and then we increase it. In this case, we kind of can't. And for like two digits, we can generate all the numbers from 96 all the way to 101, because that's the top cap. This one is 1 character longer. So we kind of need to increase the cap, the maximum cap as well. But we can cap it in 99 because the other number is the 7 isn't divisible by 2. So we know that there won't be any problem with that repetition there. So that's that. Yeah. So that's one thing. But now with something like this, if I'll try the 1, oh, that's right. What if I'm gonna do this? From 1 to 23? Because that's a possibility, right? We have this range. Or even better, from 0 to 23. I guess that means the first direction from left to right, we wouldn't do anything, but we would need to repeat it from right to left. I don't like that. But in this case, what is it? Oh, because if we're gonna... Yeah, I guess we need to keep growing the length of numbers until we reach the... Like 6-digit is nope, reach maximum. But we need to try 7-digit for this one here. Just to make sure that maybe we can repeat that one. And in theory... Oh, wait a moment. Yeah, we should try the 7-digit and see if what the range here would be. Or not. No, also nope. No. Nope will be nope. We just need to make sure that we start with single numbers here, and that will produce, we're gonna try with 1, and that will produce 11, and we check it within range, then we do 2, and that will be within range, and we basically have the first digit that we grabbed, and we cap it at the two digits from the other one, so that will work. Yeah, I think it will work out. And Anonymous was saying on line 9, why are you capping at 999? 1010 is invalid case that won't be reached. Yeah, so the whole idea here with this capping is that basically I will need to generate a range of numbers to kind of try. And therefore I know that, oh, this generates a 4, like, you know, that because we have the second number of the range longer by 1 character. That means we need to have a check to see if that number is divisible by 3. If it would be divisible by 3, then we can say, hey, this is within cap. Okay? It's gonna try all the way to here. But if it is not divisible, we need to cap it as the largest number that's the other one. This way we're gonna spare ourselves, in this case, just 13 cases, but in larger numbers could be more, I guess. I don't know. We'll see. Shouldn't grow too much because it'll be a bunch of stuff. So what I'm seeing right now is that we need to solve a few problems. I mean, one problem is, of course, how do we separate it into numbers, but we kind of have it done previously, so that's good. These numbers don't seem too large. We can probably fit them in integers or some other number format in SurrealDB. It'll be fine. The biggest problem now is how do we evaluate if something is divisible? So that's one. And then another one is actually making that algorithm to generate all the possibilities and check them. So yeah, let's get to it. Let's start by processing the input so we can kind of take it from there step by step. So we can look at one of our other programs from yesterday where we kind of did something similar where we parsed stuff. I'm gonna grab all this and we're gonna move here. All right. So we're gonna go to query. I'm gonna paste that here. So in this case, we're not worrying about any dials or passwords. That was last time. Let's just focus purely on processing our input. So how do we do it last time? We extracted it by taking the input, right? We split it. Back then it was by new lines. Here we split it by commas. And that should give us just the lines, the ranges. So now we should be able to split it again to a starting and ending range. So we can basically map each element of the split, which is, let's call it range. Okay, within each range, we will need to basic split it. So we can do something relatively simple. Let split range is going to be range split by dash. That should return us the array. Okay, so we can do, actually the only thing we need to do is kind of return this data. We would like to store it as something we can easily check, like verify. So we could just return, so let's do let result is, and we're gonna create an object. From will be integer from the split range. Let's fix that. Split range, and this will be the first element, while 2 will be the second. Okay, and this should give us the result that we can return and quickly query. Hey, give me the second instruction that we can iterate over all the instructions. So this will be ranges. Okay, we'll call them ranges, and each range will basically have from and to. And do we want them, because so far whenever we're looking here, we were operating really on digits and only then trying to convert them to numbers. And I think that would be way easier than trying to do number operations. So maybe let's just keep them as strings. Okay, we're gonna keep them as strings, and that will be the simplest way to deal with them throughout. So if I'm gonna do return ranges, we should be able to see that we have from here to here, from here to here, and whatnot. Okay, that's great. So all these exist properly. Yeah, worked. So that's the first thing. So it'll be extract ranges from text input. Let's just not have the return there. And this is going to go here. So now, what's the next step? We need to have a way to quickly check if something is divisible by the number or not. Like, is 6 divisible by 2? Is 6 divisible by 5? And simple answer, yes and no. So let's look it up. Or just, I'm gonna go with easiest option, faster for the stream. What are very simple algorithms for checking if a number is divisible by another number? I'm looking for really simple solution that applies only to smaller than 10 or like 11. I think I could just make a lookup table or something, but maybe there's something simpler. Why is divisibility important? Because we're going to apply repeated numbers, right? So let's say that we have this range here. This range here. Let me just select it. Let's go somewhere here. And if modules return 0, that'll be the reminder. Yeah, that could be one option. Yeah, absolutely. So yeah, the idea is that if we basically are generating little patterns like 1, 1, 1, 1, 12, 12, 12, 12, or maybe something like 1 to 3, 1 to 3, 1 to 3. So this pattern is consisting of just ones. So it's a length of 1. This pattern is consisting of just 2 numbers. So if we're gonna try to do 1, 1, 2, 1, 2, 1, 2, go away this thing, another 1, 2 won't fit. Therefore, we know that it's not divisible. Therefore, we don't have to bother with even generating something for it if it doesn't fit. Yeah, and that's pretty much it. You're saying modulus. Yeah, it's that. Yeah, for programmatic use, yeah, n divide whatever, module 7. If it's 0, it's simplest. Yep. Good idea. Just modulus, and that's it. Yeah, because we don't get any number larger than 10. Yeah, that's it. Yeah, modules will be easy peasy. Yeah, so we probably don't even need to create any other function. But yeah, the whole idea is to see if we need to bother generating numbers for something or not. And that's why I was checking if there are any length differences in ranges where maybe one beginning of a range is 3 digits while the other one is not just 4 but maybe 5 digits, because that would mean that we need to kind of generate for the lengths in between. Here we don't have to, so I can simplify the rules. Okay, so divisibility we'll just check by modulo. So yeah, that's it. Now we need to kind of start figuring out the loop. So the loop would be that we can go from the starting with the left one and just starting with a number of digits, right? So we start with whatever loop for number of digits, okay? And that inside of here, let's say we do for 0 digit, 12 digits. So it would be basically generate range of possible repetitions. And that will be, yeah, like for 2 digits here will be from 96 to the 101. But will be capped at 99 because the upper one wouldn't be divisible. So first one will be basically check if left or right divisible. Okay. Yeah. So we check if left or right is divisible. So let's say that we do 3-digit things, right? For 3-digit situations, we would say that, hey, the left one is yes, the right one is no. Therefore, we go only over the, we don't go over the full range. But here, the important part is that we actually know if there's a difference in lengths. Yeah, because if there is no difference in lengths, we don't need to do any other like extra checks. We have basically this. Yeah, so if we have a situation of, let's say, from 123 to 321, and we want to check for the situation for like, let's actually make it something like this one is, yeah. The range here, because it's within the same thing, is going to be from 123 to 321. But if we have 123 to 3210, that suddenly changes because we have range from 123 to 999 and from 1000 to 3210. So this is the, I mean, for 3 digits here would be literally something like that. We have like 2 kind of disconnected but possibly overlapping ranges. And that will be in case they're both divisible by 3. So I would need to, this will be the case. Which will never be the case. So when would it be possible where something on the left isn't divisible, but something on the right is? So it'll be something like 1, 2, 3, right? Versus 1, 2, 3, 4. Like this is our range, okay? This is possible within this puzzle that we have a range like this. Therefore, for let's say two digits number, 4 2-digit numbers. So 4 2-digit numbers, like combinations or whatever. We basically have from 12 to 99 and from 10 to 12. Because we cannot start a combination with a 0. Right? Yeah. Here they overlap nicely. It'll be different if it was to something like 1534, right? Then we would have till 15. But in this case, the one number on the left is not divisible, right? Because this would mean that we have some kind of overlap. But this one is not divisible, so we just straight up don't have it here at all. It's like, nope. And this is the only range that we need to check for and generate those numbers. So we have that, if we have that length disparity, that makes sense, yeah. Anonymous says, I like how you're going the route of generating the invalid IDs. I thought about it, but I found it harder to wrap my head than checking all numbers. I mean, all the numbers is just, there's just so many. For each number, I would need to check if it's within range and whatnot, and maybe that would be fine if I was going with like normal programming language. I'm going to be using a database which executes the stuff with a little bit more overhead, and that's a little bit too much for me. I mean, absolutely we could, but this is kind of more fun way to kind of try to optimize it ahead of time and try to generate only the ranges that make sense and then kind of take it from there. And the interesting part is that, you know, if we generate all the combinations from 2-digit numbers, that means that they will also show up in 4-digit numbers and whatnot. But I don't think the overlap will be that heavy, so we don't have to worry. Okay, so that will be the case here for the 2-digit combos. But for 3-digit combos, we would have basically 1, 2, 3 to 999, because on the left is good, but right is not divisible, so it'll be nope. It's just not possible here. Okay, great. But the thing is that we need to have at least 2 repetitions, right? So in this very simple case, two digits would work because we would have at least 2 repetitions, which makes sense. But for something like the starting point, this is just a single repetition. So we also say nope. And the right one doesn't fit it, so it'll be nope. So now let's look at something like this. And let's do, oops, I'm just gonna run for all the lengths from 2-digit to 3-digit. So it'll be 2-digit will be left is within range, so it'll be 96 to 99. And the right side isn't divisible by 2, at least the length, so it'll be nope. We're not generating here. So those combinations will be possible. And then, of course, will be question how many repetitions or whatever. That will be easy to calculate. Then we have 3 digits. The left side is divisible, so it'll be from 967 to 999. The right one is not divisible, so it'll be nope. 4 digits. Left side, nope. Right side, nope. So we don't generate anything. 5 digits. Nope, nope. And then we have 6 digits. So this is, we hit the limit. This is the same number. We won't be able to repeat it. Actually, all the way here, we already shouldn't be doing that. Because we can check that what's the maximum number. So max digits will be the longest, whatever the longest, which in this case is 7, divided by 2 as integer, so it'll be 3. That's the max we can go, and we don't try anything longer. It just doesn't make any sense. Okay. Okay. I'm working on part 1. I literally just started. So now I just want to revisit the case of 0 to, I don't know, 45, 44, or 45. Sure. Something like this, a case like this. This is the case where normally, okay, so the longest, right? Longest divided by 2. So the longest will be max digits will be longest, which will be 2 divided by 2 is 1. So just 1 digits. We need to check for 1-digit repetitions. And therefore, for 1 digit, from the left side, we say nope. From the right side is from 1 to the existing one, which is 4. Yeah, and we will basically check for 1, 1, 2, 2, 3, 3, 4, 4, and we say they all fit. Okay, this is starting to take some shape. All right. Therefore, I delete all this because I don't need it anymore. I think this is forming an algorithm of sort. The last thing to check is, does this algorithm work for something like 11 to, I know, 33, where we want to fit 11, 22, and 33 within that range so that it actually captures all. So if we would do max digits, will be 2 by 2 is 1. Okay, so again, we're just checking 1 digit. In this case, left side can fit, is the appropriate length. We can fit 1 repetition. So it will be basically what? From 1 to 9. Okay. But they're both the same length, so it'll be from 1 to 3, really. And that will generate all the possible. Yeah, so there'll be 1, 1, 2, 2, 3, 3, which is okay. All right. That will work. We just need to have kind of a separate situation for generating the range if they're the same length or they're not. And that's it. So that'll separate it from, like this, we have basically one evaluation. But something like here where we have two different lengths, or maybe here's more clear, we need to split it into left side and the right side. Because if we had something like something similar, 1, 2, 3, 4, 2, 4, 3, 2, 1, right? We have this range. That means the max digits will be 4, but by 2 is 2. Okay, that's great. They're the same, so we can basically say, hey, 1 digit. We don't need left or right side. We go from 1 to 4 because that's our first. These are our first digits. For 2 digits, we don't need to check left, right side. We go from 12 to 43. And that's it. And we just check those combinations. So we would have 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, and 4, 4, 4, 4. Right? From which only those two will fit. And this one will start generating like 12, 12, 13, 13, 14, 14, all the way to, 42, 42, and 43, 43. All right, so that is still a number of entries, but not as long. Okay, so this works. I am very happy with how this is gonna work. Okay. So what's the first step? We have our entries done. So now we should decide the longest, like max digits, right? So now I'm trying to think this maximum digits. Because for a situation like here, we, intuitively as a human, you don't have to think much. Like, oh, okay, if it's 2 digits, left side is divisible, right side isn't. But what about situation like here? The first one, we just marked it as nope. On the left, 1 digit we cannot because it's already the same length. So I guess we decided that, okay, we are evaluating left and right side separately. Therefore, left and right side separately. Therefore, we calculate max digits for the left side. And that's gonna be deciding if the 1 digits, wait a moment. Yeah, not only if it's divisible, but also if this is like possible to kind of fit in here. Because of one character, we have 1 divisible by 1 is 0, which is great, but will 1 fit this thing? It will return 0 and will be sorry, no. Okay, I think we can do that, yeah. Because how many repetitions that would be? So let's just run it for this scenario where we have, let's say we try to generate a 2-digit length, right? We're gonna see that max digits is within range. Okay, we're good. Because it's 3 while we're trying to generate 2. So we're good. But is it divisible by 2? Yes, it is. And we can then calculate how many repetitions because we just divide 6 because of the length divided by 2. And we're gonna get, hey, we're doing 3 repetitions. So we're all good. Okay. Awesome. So I wonder if we can actually kind of, instead of going with this big looping with loop within a loop within a loop, because, we would have a situation where, okay, now we're looping over all those, then we're gonna go and extract the first range, and check for the visibility, check for the other thing, generate the numbers for that and execute them, then go back and forth, back and forth. What if we're going to go through a little bit more iteratively? We generated the ranges. Now over each range, what we're gonna do is kind of enhance them with additional data. We could probably just map it over here instead of going any further to kind of extract. Do we have two separate left and right side? Do we have this and that? And we could probably just kind of evolve it. Like while we're iterating over all the ranges, let's take it further. Because we have the minimum and maximum range. So we can probably put in here, this will be extract from and to in the range, okay? Then the next step would be to figure out their lengths, or if these are different lengths. I feel like we could have one iteration where we go over the range and basically generate the ranges of numbers and how many repetitions to generate, kind of a list of stuff to do. So let's just add another map. Okay. And again, we're gonna name it range. I think I should be able to, because the moment we get out of here, we should have a separate context, so I'd expect it to work. So in here, the goal is to, let's name it like this, prep list of ranges to generate repetitions to test. Okay, so we'll end up with a similar thing, okay? Where we have from and to, and this will be from our existing range dot from, this will be our range dot to. Okay, we're kind of translating that, but in addition to that, we want to have a list of objects. So for now, I'm going to name it a list, because this will be a list of elements. And each element will basically say to generate from, let's say 12 to something like 15. And then repetitions 3. Okay. Yeah, something of that sort. Yeah, if both sides are divisible by the same number, I don't think we'll have a single case like this. Let me just check something. Because, yeah, I think so. Because I'm thinking, when will be a situation where, what are the possible situations where both left and right side, they're separate, as in, you know, we have their range from, I don't know, from X to Y on the left side, and from, you know, C and A on the right side, right? What are the possibilities? Because if we have both left and right side of the range the same length, we just have one range that we're generating. It's like really simple case. But if we're gonna have this split, so we have, let's say, range between just one digit on the left and 2 digits on the right, the only thing that we're gonna have to generate is really, where was it here? We don't generate anything on the left, we just generate stuff on the right, which was, nope, it won't work. From 2 to 3, divisible by, you know, single character length is on both sides. What the hell? I'm getting confused. Yeah, I think we need to separate it like that. Because in this case, a single length characters one-digit combinations will basically work for both sides. Yeah, they always will work for both sides. And we'll need to have a separate one from 2 to 9 and then from 1 to 3. Yeah. While something like 2-digit, they will be only on the left. Yeah, so we might as well just have the system for both. I know that what I'm saying is very abstract because it's something that's in my head and I don't really know how to explain it well. But, we would have a situation, generate from 12 to 15, and this would be 3 repetitions, so we'll generate like 6-digit numbers. And then maybe it was generated that, hey, we also need to generate from, I don't know, 100 to 109 in repetitions will be 2. Okay? Something of this sort. And this could be a list of those ranges to generate and how long numbers from to then check for within that very specific range. Yeah. Because we still need to check every number if the generated number is actually within the range. Okay. So if we can generate something like this, the next loop can be very simple because it will just loop over everything. Oh, we found something that's whatever, something, add it to the lists. Just create a record and then we can query everything. Yeah, I think that's possible. So this will be, instead of list, let's call it test ranges or generator ranges. Yeah, something like this, yeah. And instead of repetition, we'll just do reps, and that will make it a little bit easier to read. There we go. So now, how do we get to this result? So first question is, are those two different lengths of the, is the from and to different length? So let's do is different length. And this will be basically our range dot from and length is not equal to the range to length. Because these are just strings, so that'll be it. This should be it. This isn't happy. Do I need to, because I need to create it as a variable, there we go. So now we'll know if it's the same length or not. So let's do, Because we can decide if do this, if something, do something. But now I'm thinking, because with if statements, we can't just create a variable or add to them. We have to have it kind of ahead of time. So what if we just create 2 separate ranges or something? Let range sets or something. I don't know how to name it yet until we actually figure out what we're doing. So basically if div length, so this will be handle different lengths, but first we're gonna do otherwise, which will be handle same length. For example, something like 1, 2, 3, 4, 2, 4, 3, 2, 1, right? Both sides of the range have the same number of digits. That means that now we basically have to go and generate all the possible lengths that we can apply here, right? But do we need to have that generated loop here, or can we have it outside of it? Because for loop, again, we can't assign something to existing variable. What we can do is kind of create variable from something. So in theory, we could create a range of numbers from 1 to something, and then basically iterate over them with another map inside of it to kind of figure out. So let's do that. Let's do let max pattern digits will be basically the same thing as we were doing here, okay, which will be the larger number, so it'll be the range to length. So the number of digits in the larger divided by 2, and that should be it. That's the maximum of that we can actually fit. And then we will be able to create this kind of loop. So I believe we can create a range relatively easily in SurrealDB. So let me make it. This can go away. Where did we have something like ranges? There we go. From 0 to something. So we can check if this is inside of it. That's great. And for loops, for something in this range. And that's exactly what we need. So we can go here and say for. Oh, wait. But that means, no. We need to do the map, right? Can we map over with a like array? A range can be cast into an array. There we go. So we cast this into an array, and then we can call map on it. There we go. Construct an array and then map over it. Beautiful. So what we're gonna do is basically create the array. So we're gonna say from 1, because that's our smaller divisible thing, to, so first of all, array, okay? And they say, yeah, from 1 to, and whatever this is supposed to be, we divide it by 2. Yeah, we didn't have any situations where the IDs were from 1 to 1 or something. The second number in the range is always 2 digits, so that's great. So we'll be to the max pattern digits. So I guess we can just screw that and just paste it here, and that should evaluate, hopefully. And therefore, then we can do another map or something. Let's just do it here, and this will be the, let's call it pattern length. Okay, because this will be the length of the pattern, right? That we're generating. So one digit pattern, 2-digit pattern, right? And this we can then kind of continue. So because this is an array, so we can say, hey, just do this. All right. For each of those entries, we're gonna create kind of a new thing. So it'll be very similar to what we had here. Inside of here, we're gonna call them result. Or wait a moment. Here, our range set. Our result will be range from, range to, not really yet. we're just gonna start that we are defining here the reps, which will be whatever pattern length. There we go. We just apply it over here, which is great. And then result, right? There we go. So this is inside our map. And as we already have the length of the pattern that we're checking, we will be able to start checking if it's, if they have different lengths or not. And based on that, we'll be able to start doing stuff. So we already are going to have a lot of nested stuff. Definitely. So basically, if they have the same length and we try to fit a pattern, we just need to check if it's possible. So for the same length, we always need to check. So this is where we basically need to check if this pattern will have more than one repetition. No, that's already taken care of for us. Because this will be a range from 1 to 1. But now, how are those ranges again? From 0 up to 9, so the upper one isn't even included. So if I would have 0 to 1, it will be 0 to 0, so it's just gonna generate 0. So I think we need to basically here say this plus that plus 1. So let me wrap another parentheses, or let's just use this one, because this is getting too convoluted. Plus 1. So max pattern digits. Okay. Or let's actually do plus 1 here, because that's the case. Just the range plus 1. There we go. So this should iterate correctly. And I think maybe just to test. Yeah, let's just do a test where I just comment this out. We're going to have this result generate the pattern length. And then this will basically, instead of generating those ranges, we'll have the test lengths. Which will be just the range sets. Okay, this should be good enough to kind of try it out. And this here closes the map. Which needs this. And we can kind of get it out of here. Let's try to run it, see what happens. Okay, so for something like from here to here, we get patterns of 1 and 2. Okay, that makes sense because something like 888 would be in range, and we can do also a pattern of 2, which would be 1212, which would be in a range. Something like here, we have 1, 2, and 3. So something's divisible by all of those. 1, yes, 2, yes, and 3, yes. Something like 4 wouldn't make sense because it wouldn't fit in here. And this one goes all the way to 5. Oh, because they are both 10 in length, right? So in theory, we could have a pattern of 27272, another 27272, and that would actually be a correct ID that would fit in here. Yeah. Okay. All right, this generated correct pattern lengths to check for. So that's verified. Okay, we can rest easy then. I'm just gonna literally grab it all and kind of save it here in case we have some problems and we're gonna lose data. Okay, so now let's take care of this, which is the real messy part. So again, we're starting with the same length of the pattern, which should be easier. We already have a guarantee that it can repeat the number of times that it can repeat, but we need to calculate that number of times. So let's do let reps. Okay, the repetition number will be basically the length. So in this case, they are both the same length, so we can take the range dot yeah, let's not worry about super optimizing. Let range from the length, okay, divided by the, in this case, pattern length. All right, so that's one thing. How many repetitions? And then another thing is it divisible? Because we haven't taken care of that yet. We basically checked for just generate them all and possible things, like all the possible lengths. So in this case, we need to check if they are divisible. So what do we do first? We check for divisible, right? Yeah, and that'll be another nesting thing. Oh, this is gonna be so ugly. I have an idea. Because here we iterate over the list of those pattern lengths. What if this iteration won't generate all the outputs yet, but this will simply generate a list of just simple values like, is there a difference in length? And do we calculate left and right? And are they, is there some kind of, what do you call it? Is there some kind of, if the left side should have a range or should not, and then we're gonna do those ranges separately. Because the thing that I'm looking at right now is that in this case, when we're checking for the same length, we have a situation where, oh, they're not divisible because we have this thing, we generated, maybe we had something like this, right? And we generated the length of 3. None of them will work. So divisible will be false. And therefore, we don't want to do anything here. We need to just return one thing. But that means we have entire thing wrapped in entire if statement. Maybe we'll just deal with that, because the other thing will need to be wrapped in that anyway. Yeah, let's just deal with ugly code. So basically if, again, we can return just a value. I'm starting to feel like we should do a function calls, but I want to avoid that. So if, and here we need to do the divisible check. So let's do let is divisible, which will be the range from length, right? And how do we module in here? I don't think we'll have just an operator for that, right? or the operators? Here. Do we have something like modulo operator? Not really. I don't see it here. Mod? No, there's no modulo here. So let's go into database functions. There'll be math. And I'm sure here we'll have mod. There's mode. Wait a minute, what? To name it differently, or do I need to calculate it myself? Okay, it's not here. I'll double check the operators, but we didn't have anything modulo-like. Comparison with fuzzy matching. Divide value and all that fun stuff. Looks like we don't have modulo. I am genuinely surprised. I guess we're just gonna do like a really dumb thing, very simple thing. So we just divided by the pattern length, right? So we can actually do the repetitions first. So it's divisible. So we check if range from length, if the length is the same as the reps times the pattern length. If they're the same, it is divisible. Otherwise, we have disparity in length, and there we go. And that's it. That should give us the answer. No modulo operator. Maybe it is somewhere there. I just couldn't find it. All right, so we've got divisible. And now, depending on if is divisible, we're going to do something which will be, return data. Otherwise, no data. No range at all. So how can we deal with it now? Because we're expecting to produce, what are we producing here? Sets of ranges that we can apply here. So basically from to for that number and how many repetitions. We have the repetitions done. We just need to get it from and to. So in this case, our pattern length, we just can grab this number to this number, and that's it. So if it is divisible, we can basically return an object, right? So we need to do let result is this thing. And we're gonna return that result out of here. So this statement range sets gets here, and then we can continue. Yeah. So what should it be? It's just gonna be a range. Oh, this is gonna be single range. This will be two separate ranges. Yeah. So I would like this data I don't like this, but I think we'll be able to flatten it somehow. So if the thing is divisible, we can basically do, range. So we already have range, so it'll be new range will be something like an object from to, so it'll be from to, and we can just note that what the pattern length is and whatnot. We'll just include it all here. So it'll be pattern length will be and reps will be reps. Okay, something like this we could return. But in my case, I would actually make it that, hey, we are returning a list, because as much as this is just single element here, we would want no element here and 2 elements here, possibly. Yeah, because for single digits, we might have a situations where both left and right range have something. So we'll be flattening those in further results. So the from and to, we need to basically extract 2 first digits of a range. So we can do range from, what was it, split or not split? It was, wait, I want functions for strings. And we had the slice, right? Yeah. Okay. So it'll be slice from 0. We want 2, which in this case, it'll be pattern length. That's how many characters we want to grab. That'll be the from. And then we have 2. But do we want them as numbers or do we want them as strings? At this point, I think we already want them as numbers. So we can just say that this is an integer. No, we want them not as numbers, because we'll be combining them together into string that then we can convert into something like an actual number. So we're gonna do this, and this will be 2. There we go. These are repetitions. Bam. If there's nothing, and of course we return the new range, because we just need to return that. I don't think we can just randomly plop an object here. We just need to return as a variable. And no data, no range at all. So can do no range. So it will be just an empty array. There we go. Beautiful. We need to make it as let, and let here as well. Okay, this is ugly, but it should work for this very case, at least, of the same length. Now, the different lengths means we need to do separately for left side and right side with checks. But for now, let's just do let fake result, and it's gonna be just something like note fake result. All right, we're just gonna return that string. And that will be it for here. So let's just do to do so that we're remembering. So we have the situation where, of course, we're missing some icon. So this here, the range sets, that will be basically 0, 1, or 2, array of 0 or 1 or 2 elements that are for the specific pattern length. Therefore, what we could do here is a result, we could kind of flatten it. And I think we have some helpers for that, like array functions. Let's look at it. We have, I recall, we have fill, we have flatten. Where flatten function flattens an array of arrays, returning a new array with all sub-array elements concatenated into it. So if we have array, and element, another thing, it just, oh, that's what it does. Okay, so that's good. Because if we have, wait a moment. Okay, we had a subarray here. We will have actually an array of objects. Yeah, geez. Okay, so results will be basically take the range sets, flatten, and we can put it as a result. And wait, this is range sets. Oh, because we had range sets within range sets. Oh, geez. Ranges for pattern length. Okay, let's just name it this way. So it's a bit more descriptive. We're less confused about this whole thing. Okay. And therefore, this is it. This is our flattened array. So text lengths, we're gonna do that. Okay. Let's run this code and see what happens. Problem, using the map function, no such method found in the array type. Oh, which one? An array type. How can he not map the array type? That's what an array type is for. We have our code and we have this here. We have an array, right? From and to. That's an array. And we should be able to map over an array. So why isn't it happy? Do we need to extra wrap it because this thing broke parsing or something? Let me just double make sure. No. Oh, and this is the whole query, so I don't need to select nothing. Okay. So what is the problem here? There was a problem running the map function. No such method found for the array type. Is it inside the map function, or just that we're not calling the map in a proper spot? How about if I comment out everything? There we go. And we just return. We did go over them before, right? Pattern lengths and all this stuff, we generated them. So let wolala is whatever pattern length, right? And we return wolala. This should work. Okay, test lengths, and we got the test lengths for every single thing. So that is good. So it's not the problem of this. It's the problem of some other map. Come on, Go away. Uncomment everything. There we go. So do we have any different map in here? Because I don't recall mapping in here. No. So it's just a problem that we're trying to call. Oh, there we go. Ha! That's probably it. Not really. Not the only mistake. Okay. So let's start looking for mistakes. We know that it's only within here. Yeah, only within here. Let ranges if diff length. And then we get this. We take this. Create this, which should be absolutely fine. And return it. That's good. Yeah, else. I'm looking for syntax errors, range from length. That's good. Pattern length. That's good. In 3.0, I believe we're going to have a little bit more helpful error messages because like they will cascade a little bit further. But not yet. For array type, flatten. Right, that was flatten. Yeah, flatten. Mm-hmm. Yep. Result if it's divisible. Create this thing. We have properly closed. We just do simple slice, which is fine. And ranges for pattern length. Yeah, every time it's a list. But it's a list of elements. Wait, this is a list of elements. This whole thing is a list of elements. Wait a moment. We could do this map. Okay, this is where the map ends, right? Begin here, close here, begin here, close here. Yeah, and then we do that. Ay. No, we open this one here. Okay, yeah. You're a very unhelpful error. Okay, so this should be fine. Let's also copy this and paste here. I want to kind of start getting stuff ruled out. I'm gonna run it now. We got proper fake result everywhere. Just a single one for everything. Good. That's awesome. So this is, the problem is definitely somewhere in here. So handle the same length. We have repetitions. Is divisible. And let's copy this and just paste it here to rule this part out. Run. Okay, so the problem is somewhere here. Where though? Range from. That should be fine. Length and divide by pattern len. We should have it. Yes, we should have it here. So this is the map that we're having issues with. So pattern length, that's correct. And then create another one is visible. Range this equals to. Oh, that's probably what it is. we kind of have this equals that, and this is unhappy about that. So something tells me I will need to run comparison with some kind of if statement rather than the way I have it now. Oh, how fun. If this true, else false. I think we need to do it this way. And we need to add semicolons here. Let's try it. No. Why is that? Comment this one out. We already have an error. Oh no. Problem is here. What? Comment both out. It's all good. Comment this one out. Very unhappy. What am I doing wrong? Range from length divided by pattern length. What's wrong with this line? We have this, yeah. Divided by 2. No, it's unhappy. 10. Oh. Range from length. It's unhappy about this one. Why? We have range. And range already has from, which we're already using here. What the heck? Do we need to wrap it or something? That'll be new. If I'm gonna do 10, right? That's a number. It's happy about the number. Do I need to say, hey, this is an integer? Is it that dumb? And that this is an integer as well? No. Okay, I am very confused. Let's make a quick little test. I'm gonna create a new query. We're gonna test the same thing. Let range to be an object that has from, which is maybe 12, and we don't even need a 2, just that, right? We have our range. Then we have pattern length, which is, I don't know, 3. Okay. Return reps. This should work. Yeah, it returned. It works. It has no issues. Is it maybe we're nesting too deep already? And that's the problem? But we're not doing like crazy deep nesting. If one map instead of which we have just another map, and that's it. And I don't think we're reusing anything because we have our range here. Okay. And within here, are we using the range? No. So maybe it is that we can't use this range in here because we're already using it here. Then how on earth would we pass it inside? We need to create a local variable that's gonna get captured instead. Let local range. And therefore we'll be able to do this. No. Doesn't like it anyway. Okay, let's simplify it a little bit further. So let's say we have our range. We believe the things were the way they were. But instead of fake result, we're gonna specify our fake will be whatever our range data. We just our range dot from. Can we do that? Range data, none. We don't have range data. Oh. We don't have range at all? Yes, the range parameter is not populated. Okay. All right. What the heck? Local range again is range. So we go and do all this fun stuff. Local range. Let's call it range 1. And this one has different number, but we were already doing it correctly. There were no issues with that. Having one range after another, right? This is passing. What if I'm just gonna say, hey, the range data is div length? Again, none. What the heck? Okay, we're going one step further. We're verifying this whole damn thing. We are getting rid of this. And here, fake result. And we're gonna say is div length. Right? It's div length. Unless we just can map after map, but no, we were doing stuff correctly. And max hat. Oops. Let's just return all this. Right, all this, and therefore all this can go away as well. Messing it all up. But yeah, these have correct numbers. True, false, and whatnot. And they change, right? Depending on the range. So we can even throw in range, which will be the included range. There we go. run. And yeah, this is available here. Okay, great. Why can't we use it here? Not sure why. Assigning it to a different variable should work too, right? Let local range is range. And therefore, I should be able to just plop it here. And yeah, you run the query and range is included. So why isn't it available here? So I'm gonna grab that and do this, and then we're gonna do a very simple version of it. So the range is included because we're mapping over it. Therefore, everything from here is not available unless it's in here. This is weird. Okay, we got that. So I should be able to do the same thing here. Therefore, we do this. And this. Or not, sorry. Here. Okay, the database is defeating me. I think we're gonna switch up to a different approach where we just, maybe instead of just doing this, we map over it and then map over it again, or do some weird loop stuff. Let's try to do it in a different way. We're gonna do it where, where after we map over everything, we have our list of, our list of ranges. What we're gonna do is we're gonna extract those two values, and then instead of calculating it here, we're just gonna save each one to a database as sending the query. Therefore, after that, we can just have a query to just grab all this data and iterate over it again to kind of get a little bit further. Or like we're gonna generate the ranges to check or whatever, but no further. And we're gonna split it up. It's gonna be less optimal, but hey, it's gonna be more database-like, right? So maybe a little bit more fun. So we could actually do it probably differently. What if we're gonna do upsert, and we're gonna do temp, and this will be range data, and that's gonna be very simple. Set, and we can just do is div length is div length. Okay. Then we're gonna max pattern digits. Max pattern digits. And lastly, range. Okay, so we're gonna just update this. And then down here, inside this loop, many times we'll need to basically query it. So we're gonna do select temp. Select everything from temp range data. All right. And this will be from only. And this will be select, not value. We're just gonna select everything. And this will be our range data. And we're gonna need to kind of extract it from here. So we should be able to kind of do it here. Max pattern will be this, and this. That's what we should be able to do. And we get rid of this. Run. Couldn't write to a read-only transaction. What? Oh my. Okay, I see. So because we're mapping over it, mapping is read-only because we're going over okay, I see. Yep, we'll need to do it a little bit more manually. Definitely. Okay. I'm gonna go for a short bathroom break. So give me 3 minutes and we're gonna re-implement that and it's gonna be working well, I hope. Be right back. Alrighty, I'm back. Okay, so the main problem is that we try to map over a map, and that inner map doesn't get what it's supposed to do. So that means that we can kind of generate those, right? Those patterns. But instead of mapping them, we're going to have to, I don't know, just save this range and then go over them in a loop. And from then start to kind of collecting stuff in a more database-like way. I think that would be good enough, yeah. So let's see. So what we can do is we have our range here. Or we can probably even simplify it further. Let me think. I know, let's just make it this way. So this will be, instead of calling it range sets, let's do let pattern lengths. Okay. And we're going to say it's just the array from here to here. Okay. That's it. That's the pattern lengths. And I'm going to uncomment all this for now. Get rid of the fake stuff. And we had this thing here. And this thing depended on internal stuff that we don't have access to right now. So we can get rid of more of the fake random stuff. Okay. And this is the stuff that matters. So I'm going to grab it from here. I'll just grab it from here, yeah. So we have pattern length. Yeah, plural. And we basically were trying to return that, hey, we need to flatten stuff here, but not really. We are just over each range. Oh yeah, this is not even like here at all. This is not a part of it. We're not gonna loop over it. This is what we need. So it'll be from to range, and then instead of lengths, we're gonna save the isDiff length. Okay. I'm gonna save max pattern digits. We're using that somewhere here, right? Oh, we don't need to save that anymore, right? Because we were doing it here, so no, let's save that for now. We'll see if we need that or not. And lastly, yeah, we are not doing this. Nor this. What a mess. Pattern lengths. There we go. Pattern lengths. And that will be it for now. Okay, good. That'll be the result. And all this can go away from now. I'm gonna plop it at the end and just comment out. We're gonna get back to it. I want to just see what happens with this query right now. So we basically end up with an array of from to and isDiff length, max pattern digits, and the actual patterns to generate for each. So I think now it will be time to kind of create a for loop that will go over each one of those and then do more stuff, right? I'm just like confused. Why can't I do it inside of this little what do I call it? Map within a map. Don't know. Don't want to think about it too much for now. But considering that this worked, right? We have our, basically, these are our ranges with extra details. Now, instead of returning them, we can kind of create a for loop where we're going to go over them, and instead of returning them as one cohesive list, we can just kind of do database operations, and maybe that will be not the slowest. We'll see. So let's do for range in ranges. There we go. And this is where we can put our code. So let me just uncomment this and we'll be able to kind of clean it up and adjust it to what we're actually doing. So we were doing the range sets, which we're trying to iterate over the stuff. But in our case, we have the range, so we should be able to do range dot pattern pattern lengths. So let's call them pattern lengths. Okay, pattern lengths, and normally we'll be able to kind of map over them. And I think we can actually do it here because we executed it straight from here. So we'll see if it just magically works or not. And therefore, if it works, we'll be able to have just one entry with multiple ranges or whatnot per specific range and kind of take it from there. So we have this where we can probably unindent that a little bit. Yeah. So basically for range and ranges, we take the pattern lengths and ranges for the pattern length. Okay, all right, yeah. Ranges for this specific pattern length, yeah. Yep. So for now, we just didn't do that. So this will be fake result, just, empty result. Let's just do not implemented. Okay. There we go. And here we're going to have our result is divisible, not divisible. Another typo. We did our ranges checks and whatever. So that yielded the result. So that's great. Okay. And here at the end, we basically needed to do result is ranges for pattern length dot flatten and return or just result. And that should return it from the map, right? So we have all the ranges in set. So what we can do now is relatively simple, where we can just do absert, and we're just gonna do it in a relatively simple way, right? So let's do let's do temp ranges. Temp ranges set, and this will be Phase 2. Let's call this field phase 2 plus equals the range sets. We'll try that, but that means that we need to kind of, before we started, absert. This was temp ranges. Set phase 2. It's just empty array, right? And therefore we'll be adding those. And I just want to see what happens. Run this. It ran like instantly, which is weird. Explore, temp, refresh. We have our ranges and we have tons of empty arrays. Why are they all empty? Because I probably am not extracting the values properly, right? We haven't adjusted the fact that we have our range and ranges, range sets, and we have our pattern length. Yeah, our range. So we have if, and this doesn't exist, right? So range dot is div length, okay? And we do that. Otherwise, result is range is divisible, new range, and we do range dot range from, and range dot range to, because why not? But we actually don't do that, right? So we just do this and that, right? We didn't add that, yeah. Okay, that's good. Okay, pattern length is a local one here, and repetitions, reps. Where do we have reps from? We didn't save it. Oh, because we have it uncommented, right? Of course. Repetitions is range from, pattern length, good. Is divisible. Ah, there we go. Here we're kind of doing it because we didn't do it earlier. Range from divided by reps, pattern. Okay, that's good. I guess we'll see if that works. Oh wow, there were so many problems with that previous query. And therefore, we don't do that. We just do that. And maybe did it run? Like, okay, no such method. Oh no. Oh no. So what's going on here? What is the problem we're getting now? Because maybe it all just worked, but I'm doing something wrong. Let's just do it's divisible. Yeah, let me just check all the variables that we're getting, because range should be available 100%. Not if div length, is div length. That's number one. And not implemented, bam. Otherwise, repetitions from length. That should be fine. Is divisible, range from the repetitions and pattern. It's either true or false. That should be good. Let result if is divisible, so that should be good. New range is from to Pattern length and repetitions, that's good. And we return new range here. No range, whatnot, whatnot. Let's remove the flatten and see what happens. Nope, that's not it. Okay, we're going back to our fake result debugging. So we're gonna do fake is fake. Okay. I'm gonna even double it so that it's correct. Or no, it should be like that. Yeah. And there we go. So we'll be able to just grab all this and get it out of here. Okay, let's run it. We have no problem. Okay, great. So let's just do select everything from temp ranges. Just to have a quick overview. So everything is fake. Okay, that's good. The only weird stuff is that for some reason, we always go here. Like always. It's never is different length. Is different length, right? Doesn't mean our range is wrong. Let test range. Okay, and range. We can kind of comment everything out again. I mean, all the way to here. How is it that we have none again? So when we map over the range pattern lengths, for each one of those, we don't have access to range anymore. What the heck? What if I'm gonna do something as stupid as this? Just run all this. I mean, that won't do much, so not really. Return. There we go. It should just straight up finish instantly. Query 1, query 2, and this is query 3. Okay, we return a single range. So that has pattern lengths and everything. It's all okay. What the hell am I doing wrong here? We have our range. We are able to iterate over the entries, right? because that suddenly returns phase 2, and we have just tons of those added. So that's great. But for some reason, we want range sets. Wait a moment. I'm going to return this. Oh, return test. Yeah, the range is not set. Range is none. So I have the same example. So basically, within the map, we don't have access to absolutely anything outside of it other than down here. That means I would basically need to prep our range in some other way to, I don't know. I would need to iterate over, oh dear. I would need to map over ranges and kind of return a list like inverse rather than having a range with list of patterns inside. I would need to have a like permutations of those. So basically a lot of copy data. But in this case, it could be possible. Yeah. So we have those pattern lengths. We have the range here. So instead of returning something like that, I would basically need to... Do we have like some helpers for that? Array functions. What the hell do we have? Adds an item to an array if it doesn't exist. All, any, at, append. Combines all values from two arrays together. No. Complement, clump. Returns the original library split into multiple arrays. Don't care. Difference, distinct, fill, filter. We need to kind of fold. Applies an operation on an initial value plus every element in the array. Return, wait, what? Array initial value closure. It's commonly used to sum or subtract. Oh, we have 100 AB, and that will, okay, so this is like whatever, reduce in JavaScript. Group, insert, intersect is empty, join, last, length. Every element in an array returning the final result. Yeah. Remove, repeat, reverse, sequence, created an array of sequential integers, shuffle. (2D) array transposition on arrays. Don't think. 0, 1, 2, 3. Yeah, that's not what we want. Let me take a look at the fold again because I'm getting confused. For some reason, dealing with a database kind of breaks things here. Then perform the following operation. A is 100, the initial value. B is 10. Operation is A minus B, so 90. 90 is passed on. It's 90. Yeah, so this is like relatively simple, yeah. Okay. Oh wait, maybe we can actually use that. So we folded where we go over our generated list of, numbers 1, 2, 3, 4. And we can also add our existing range that we got and then combine them here. Okay, maybe we can do that. And this way we're gonna end up with a nicer object, right? Do we have access? Yeah, we have access to the first object. So let's see. So we're basically iterating over each range. So each range here should return its like list of this stuff. So we have pattern lengths. So we should be able to do pattern lengths fold. Okay. And we're gonna say that, can we use outside stuff here? No, this thing won't have it. So we should be able to do something like, this is an object where range is range. Okay. And yeah, let's do range is this, and permutations is nothing. Okay, and therefore next one will be the closure, where we take the state and the pattern length and do our stuff. So in our case, what we're gonna do is we're gonna basically say that, hey, result is the, what is it? The object again. Range will be the state dot range. Okay, so we pass it on, the same thing. Just create a new object or whatever. And then permutations is state dot perms dot append, and we just append the a new object. So it'll be new perm. Okay. And that will be it. That will return result. So we basically need to say that new permutation is, and in this case, we're basically specifying that this new permutation is the thing that we wanted to return here. Okay. No. Oh no. Range data. But range data, because I need to kind of try to put everything in here, right? Range data is, and we basically specify all this. From, to, and all those three little things. But we don't need the pattern lengths in here. We just have this. Okay, so that's range data. So range data will be passed on here. We'll call it data. So the new permutation is going to be the same thing as this. So we need it all. Oh gosh. I'm sure there's a way to extend an object, but no patience right now. Right, so we've got this. And instead of doing this, it will be data from to data is diff and data max pattern digits. Okay. That's good, but also we need to add the pattern length. Okay. That's our new this, and here instead, okay, so that's that. What the hell's going on here? And this was range data. Just call it data. Right, that's it. And this will be the new permutation appended here. So yeah, the range data, this and that. So, oh, that's right. State. Let's still call it state. New permutation will be state dot range data, whatever data. Here will be again state data 2. Okay, cool. Isdiff length will be state data this, state data that, and pattern length will be just pattern length. Okay. And then we're gonna do, oh, this is so ugly. Okay, and then we just create a result, which appends this new permutation, data permutations, and we return that result. Okay. And that's basically our fold. So we let folded. Okay, so that's in our map. We might end up actually doing it all just within this map. Okay, so that's that. And instead of having this result, we just return the folded. Okay. So this whole thing is now in the shape of this thing. We have data and a bunch of permutations. So basically out of that, we can just take permutations, or more like, oh, because we are still having a list of those elements. Yeah. So we can do map and extract those now. So this will be the folded range. And that will be simply extract the folded range dot perms. Okay, so that's another thing. And finally, we do Latin. And let's just comment all this out because I want to see it with my own eyes as what the hell's going on. Turn ranges. Okay, problem running. Of course, there's a problem running it. Why wouldn't there be a problem running it? Why does it keep jumping nonstop? It's so annoying. Never ever show me this thing again. So instead of having this here, Let's just return or whatever the range data. Okay. And we'll just skip this thing. Let's see what happens. The from, diff length, max pattern digits, and 2. So that's what's the initial thing, right? And this is somehow confusing it, right? So let's just try this. Yeah, that was a problem. I am doing something wrong. So this is the initial state. Do I need to extract it? Let init state is this. Okay, and this will be just init state. Will this magically fix it? No, of course not. So we call this one to be state and be the other one. Let's look at the docs. A minus B. And that will be applied as this one, so that will be next A. Yeah. So this will do. A is 100, the initial value. B is 10, the first item in an array. Operation is this, so it resulted in 90. 90 is passed on as A. And this reads another one. And that's pretty much it. Okay, is to reverse a string. Yeah, we just reverse it, yeah. Modify string in some other way. Don't like white space. Actually, we use to generate an array of values that can then be passed to statements like insert for bulk insertion. So exactly, we have a, an array of something, and we fold it as an empty array. What's this? And what's that? Oh, just an I as an index. So we basically ignore this one and add a third one. All right, so that's the index. We don't care about the index, so that's fine. And then we do some crazy shenanigans. Okay, so something tells me I have just some relatively simple problem here. Unless, again, we can use fold within a map or something. But pattern lengths, that should be just, yeah, it's just a list. So that should be fine. I mean, it's just an array. Just to make sure, I don't know, it was fine somewhere else, right? Yeah. I mean, there we go. Okay. So range data was doing well. So init state, that's fine. And we fold with this init state. Looking at the syntax, I can do they do something? Yeah, they do it this way. The stuff and return, and that's it. So yeah. Wait, am I appending wrong way? No, I'm appending correct way. So here we create a new object with this. So can I just do return the new? Of course that won't work because that will be messed up. But can I just do data is data? Oh, right. We don't have just data. That's where the problem is. It's state data and state data permutations append. Still not. Yep. Max pattern digits. Let me just make sure this is actually correctly calculated. Oof. What's going on here? Where does it see folded? Problem parser unexpected end of file. I am returning the init state right here. Map. Return this thing here. Oh, no, it just didn't react first. But yeah, data for every single one is correct. I can even throw in the pattern lengths. And it's gonna be still fine, right? Pattern lengths, each one is an array. So that's wonderful. Yeah. Permutations is nothing, so that's good. So we know that this is correct. What if I'm gonna not change the initial state at all? It just goes. Okay? We're not using the other ones. It's none. Huh. Okay. Something's not working here. That's for sure. Oh, because it should be state. Okay, so each one is basically the same. Or is it? We have here from 2, from 2, from 2. And why are they like that? Why is it just 1 per each? Shouldn't it go to pattern lengths in plural? And for each one of them do stuff? $8.24. Do we have anything else of $8.24? No. And with $8.24, yeah, it will be just that. But this one should have more than one entry. Well, it does have only a single entry. Yeah. Folded is all the pattern lengths, so that should be multiples. So it'll be init state within, oh, because, yeah, that's right. Normally there would be permutations. Okay, so that's good. So what if I'm gonna, is there like extend object or something instead of building it? Do we have like object functions? Entries extend an object with a content of another one. So name this extend with gold last updated. And okay, so in theory, I could say state.extend. And we just pass it a new object. In this case will be perms is, and we just straight up set it to have the pattern length. I mean, that should be fine, right? That's like the most basic usage of this thing. And suddenly it's like, oh, no such method found for this and that. What the hell? New state is this. Okay. We extended it. We replaced the perms. Why? Just why? Why does it suddenly change it? Because we're trying to modify the state object? Is that it? But it shouldn't really modify it, it just should return a new one. New field updated in the final output. No, the same behavior could be also retrieved using the plus operator. Let's try the plus operator. State plus this thing. Can perform addition, this and that. Why not? You just showed that one can do that. Grab this object, add that to it. What? From entries. Bam, bam. Great. This is so silly. Here I will try this as new permutation. So let's just do this. How about that? Screw this thing. If result is data is state data, right? And perms is this. And let's just do, for now, instead of this whole thing, we're just gonna have same thing here. This was trying to do that. And then return that result, okay? Okay, now 3, 5. So the last one is okay. So what if perms is state.perms append whatever pattern length? Will that be a problem? No, now it's not. Okay, so we're moving forward. We are moving forward. So we are able to do that. So that means our problem was here. So the new perm from state data from state data to is div length. State data is div length. And max pattern state data this, and pattern length is this. So why wouldn't this work? Oh, now it works. I guess I made some little typo somewhere. So we have data perms, and we have all the from 2, and whatever. Okay, so that's progress. Oh, we had state data perms. That was the problem. Okay, that's the only difference. Figured it out. Long way around. But now I should be able to map it so to extract the perms and then flatten, right? Now we have from here to here, multiples. Yep. Just a long array of all those where we have the ranges from 2 is different length, max pattern digits, and pattern length, and we can basically process them as a single list. All right. So prep list of ranges to generate repetitions to test. Oof. Okay. I'm gonna basically array of, and I'm gonna grab this and copy it, and here just comment it all out so that we have some kind of reference of what the object looks like here. There we go. And we can continue with another map because we love maps. And this will be basically pattern length. So this could be, I don't know, pattern data. Okay. Sure, let's name it that way. And we're gonna probably need to again, after that, just do flatten. We'll see how that goes, but yeah, I'll be back again in 3 minutes, but we're closing on finishing that. It just takes so long. Alrighty, I'm back a bit earlier. Okay, I figured instead of calling it pattern data, let's call it pattern definition. Definitions. So we have from, we have this and that and that. Let me actually grab it all, save it in a file. Yeah, let's actually not even do that. Instead of saving it to test input or whatever, we'll just change it to input. Okay. Let extract ranges. So yeah, it's just gonna be input split like that. So we can just do that and then we extract all the other stuff. Yeah. Let me just group, maybe not everything, from here to oh, because these are all commented out, right? The hell? We have all this and that. And I just didn't include this one, right? What the hell? Array of definitions? Something's not right. Oh, this fun stuff. Oh, I just haven't pasted it yet. Yep. Duh. So we can just copy from the extract, yeah, to the end. Copy. And we're gonna go from the extract to all the way here. Okay, good. So that means we can just grab it all and have it not reach out to the database at all, just everything. Oh, why did it stop? There we go. So this should still work. Run, and we get our empty stuff because what are we returning? Return ranges. Oh yeah, and we just mapped it to absolutely nothing, so we have nothing. Yay. Yay. Alright. And we'll just get an array of yays. There we go. Beautiful. Alright. So we have the pattern definition, and now what we need to do with it is kind of stuff from here. Basically, for each range, we need to range definition, we need to kind of expand it with some additional data. And I wonder if we have to do it here or we can actually do it within the fold. Because within the fold, we already have all this information. So why bother going through definition and redefining it again, inserting all this data? Well, we can kind of try to decide stuff here. So initially we had for the range and those ranges and all this fun stuff, we were going over the pattern lengths. So that's what we're doing now already. And we don't need this random test stuff. And then we basically have ranges for pattern length. Okay. So for each one of them, we will return additional data, right? And this is where we can all like build it up. So let's grab all this. It's just, we don't need this. We don't need that. There we go. I'm gonna uncomment this. All right. Then we can move back here and comment it more. Okay, so ranges for pattern goes all the way here. Yeah, let's just grab this and we're gonna shove it all the way in here. So that was the new permutation, but instead of kind of returning it here, we need to figure it out a little bit more. Where's my stuff? Else, let, wait, what? There we go. There we go. So confusing at times. Okay, so we open it up here, and now we basically need to, for each pattern definition, whatever. Definition needs to may have multiple ranges. The pattern 4. Okay. This is already adding delay. The formatting here is just so slow for some reason. Okay. So instead of calling it folded, let's call it pattern defs. Okay. And we're gonna have it here. Okay. So for those pattern definitions, we'll have those, and basically pattern length is this, and we'll be able to add also ranges to generate. And it'll be ranges to generate. Okay. So ranges for pattern length is, we'll probably rename that, but is different length. So this is where we need to kind of figure it out. How did we get it? Is different length. State data is different length. So it'll be all starting with state data. State data is different length. If it is, we just return list of nothing for now. Otherwise, we have the fake stuff and we can leave it for now. And then, do we want to flatten it? Yes. Because it will be list of lists. Wait a moment. List of an object. How do we flatten that? What the hell? This is just a single pattern. For that pattern, we just return a list. So we don't do any flatten, nothing like that. We just rename it to ranges to generate. And that's it for now, at least. Run. And we have a bunch of EAs for now. Let's just return what we had, which is pattern definition. Okay. Ranges to generate. Empty, empty, empty. They're all empty. Some of them are fake. Good. We're moving forward. Now we can get rid of this random fake stuff and start handling the same length. Okay. Grab this, and what do we have here? Repetitions, which will be state data from and pattern length. We already have here. Is divisible if state data from reps. This is all good. Now result if is divisible, then new range will be from to. Let's actually do pattern len. I like the len more than the nasty GHT at the end. Bam. Yep. State data from, state data to. This good, good, good. And here is no range. This is good. This is good. Okay, let's try it now. Oh, it generated stuff. Look at that. Why is it empty? Oh, because pattern length 1. Why is it empty? For 824 to 1475. Ranges to generate. Oh, because there are different length. These are again different length. And here, ranges to generate from 2 to 2. And then another one will be from 27 to 27. Pattern length, okay. So we basically just added that from 2 in that range. Because they're all the same, we'll just have a single item here. Okay. All right. Okay, that's not too bad. We'll probably be able to fold over it in the future to actually get all the stuff to generate. Yeah. Okay, awesome. So we have generated for this part. Now we needed to handle the different lengths. Okay, we're getting back to that. Gosh, this is long. Long and ugly. Okay, so instead of having this to do here, handle different lengths. So that means we'll need to have left and right side. Normally we're checking if it's divisible. If it is, then great. If it's not, then not. So here we'll need to basically, for the left range, we need to check divisible for the other one side. For the other side, we're doing the other one. Because there are different lengths, we'll basically need to have two separate lists. So let is divisible left. Okay, we're gonna copy this. From length is divided by this. That should be all fine. Why does it complain about this already? That's left. We need the right. And this will be 2. We divide by this and whatnot. We're all good. Again, this is complaining here. So, all right. Those two are done. Oh, repetitions and whatnot. Repetitions left, repetitions right. Reps left. And reps right. So for the left, and here we right. Okay, that's good. We got those 2 repetitions. And I should be able to just return whatever. Hi there. And it should be fine. Expected delimiter. Why am I missing F here? There we go. Now it's correct. Okay, good. So we'll basically need to do the left and right side, and that's pretty much it. So very similar. We'll need left result and right result. So let's copy the left result because I think this will be the easiest to deal with. Okay. So let's do result left. So if is divisible left, right? If we can do stuff on the left, and then the new range is from here to, and now we need to like find a maximum number for the thing on the right. It should be the maximum number possible within that pattern length. So it's just a bunch of 9s. That means we need to find a way to kind of generate that number of 9s. We can probably do something very similar to what we did in other spot, but I want to look at array functions again. Combine clump fill. Fills an existing array of the same value. So array fill this with 10 and we just bunch of 10s. So we don't really want that because we want to have an array of specific length, all with some kind of number. Concatenate. Repeat. Creates an array of a given size with specified values for each element. There we go. So we get, say, basically array repeat that thing and whatever, right? So we could just do the 9s and however many times we need to. So this thing will be array repeat the number 9, the pattern length times, and we just need to kind of join it into a string. Do we have something of this sort? join returns concatenate value of an array with a string between. So there we go. Beautiful. So it'll be dot join with absolutely nothing between. There we go. So this is how we generate a bunch of 9s. So that will be our maximum value. And what's next? Because this is, again, divided. The other one will be kind of longer. Pattern length, repetitions. So that's that. Okay. So that's gonna be this, and no range is here if it wasn't divisible. So the other one will be very, very, very similar for the right side. Result right will be is divisible on the right. And if it's and if it is, we do data 2, so the target value, right? So that will be the actual 2, will be just those 2, but from this is where we do something different, because we need to have number of zeros that are pattern of -1, and we need to join them. But I don't know how this is going to behave in case we have 2. So let's just go to our separate little test bench. Let's try that. Array repeat. So we're just going to return the whole thing, that whatever it does. Return repeat 0 if we say, let's say, I don't know, 3, right? If we're going to do that, we get 3 zeros. We're going to do 1. We're just going to 1. What if we have 0 and we try to join it? We get empty string. So if we would do 1 plus this thing, we get 1. If we have 3, we get 1000. Perfect. Okay, we can do that. So in here, because we need to start from either 1 or something to make it work. Where'd it go? We went to result right, and this is result. Yeah, result right. So we go from 1 plus this decreased by something. So might be no zeros. If it's just 1 digit, 1 minus 1 is 0. There'll be 0 zeros at the end. So it'll be just 1. So this should work. Pattern length is still the same. Repetitions is still repetitions right. All right. Well, this will be repetitions left, because these are different too. Oof. And then at the end, what we're returning here is basically result is, that's what we did it as a result. Yeah. So let result is an array of result left and result right. And return it. Let's see what happens. Do we get an error? Oh, we don't. Look at that. So in here, oh, we return them as arrays, array of arrays, and with an optional object inside. So nope, we don't want to do that. We don't, whoops, we don't need to return those here this way. So this is handle different lengths, result left. It doesn't need to be wrapped in an array. Okay. The same thing here will be just none. Sure. And then sure, let's call it none for now. We'll figure out how to filter out later. And the right result again will be just an object, and none here as well, and therefore we'll be able to return this. So we run a query again. And we have this. Ranges to generate is this and nothing. This one cannot generate anything. Okay, so there we go. It cannot generate anything. Just two nonce. It'll be flattened to absolutely nothing. Okay. There we go. I think we have all of those cases covered already. And these are the ranges we need to generate to be able to do something with it. So again, let's select everything, copy it, and just save it here for now. So we have everything. All this gets replaced with actual content now. Beautiful. So, oh my goodness, that's just a mess. So we know about those digit combos. If we can generate those patterns now, we just need to check if they are in a range and kind of add them up together. And that's it. So how could we actually do that? Because now what we have as a result is this, which is from, to, and additional ranges. So if we went to do through 4 and do a bunch of stuff here, basically if we're to map these, we wouldn't have access to here, but we could kind of fold it. So we might just try to do that. Instead of everything in one and there, we have the definition of a pattern. We have the ranges to go over. So we can basically do all that. Yeah. We could map over them. No. So the big question is, how do we collect all the results? Right? How do we collect them? So what I'm thinking now is that we'll need to remove duplicates. We'll need to do a bunch of other data. Let's actually do it that we're going to iterate over each one of those. Okay? I'm going to iterate over it. And then we're going to basically map this quickly, whatever, or just iterate over it again with a for loop. And then we'll basically create new elements in a database, like an item with a pattern. We'll use an upsert so that if the thing already exists, we just ignore it or just, override it. And therefore, we're going to avoid situations where we have, duplicates. We can, at the end, just query everything and count up and whatnot. So it'll be relatively simple. So I think that's what we're going to do. So I'm going to actually update this to have it more like, in the beginning, there was a nice little example of something that has both values. Okay. So here, there we go. We just need to replace this. And whoa, that's so laggy. I think we'll need to switch to new Vim because this is just lagging so much. I mean, it's such a short query. What the hell? I guess the syntax highlighting just freaks out. Or maybe it's just Electron on my computer. Who knows? So we're just gonna do this. And this is an example of what we're dealing with here. So I'm just going to grab this because we haven't changed a single thing besides this part, right? There we go. So yeah, we have our array of patterns definition. Now what we need to do is, actually, I'm not doing any flattening or anything else, right? Because it's just an array of those and nothing besides it. Yeah, array of objects. So we're not gonna map over it, nothing. We're just gonna, these are our, maybe not ranges. Let's call it pattern definitions, okay? These will be our pattern definitions. And that's it. All right. We have this saved here, so we don't do that. So now we basically need to have, well, we'll need to have some kind of for pattern definition in pattern definitions. And we can go over them. This is gonna be struggling with it. So how do we do that? We need to go over, so we can, okay, so we have access to the pattern definition variable. And then we basically need to iterate over each range, generate the list of possible elements, or just for loop over them, and check each one of them. And that's it. And if we have a match that everything works, you know, it's within the range, then we can actually commit it or whatever. Add it. So let's do that. So we have our from, we have our to. So we can do another for, and this will be the sub pattern. And this will be pattern definition. I hope I can access stuff from within stuff. Pattern definition. Wait, yeah. Dot ranges to generate. Okay. And I see that's how it wants to differentiate. Huh. What did I just do? Go to the end. Okay, so how do we generate from to? I think we can just do a list. So again, it would be, could do for, and we go from sub pattern dot from and sub pattern to. So this will be how would we call the 2 letters, the 3 letters? So this will be the I don't know, word. Let's call it word in this. And you know what? Let's call it definition, subpattern definition. And this will be subpattern. We really want subpattern definition. Definition entry. Let's call it like that. Oops. What the hell's going on? My hands are really cold. And I'm having trouble to suddenly kneel them. So, yeah, now we just need to generate the pattern, right? So we can just, where did that come from? Do I have tab completion? Weird. I know I disabled tab completion, so that's strange. So we just create this will be pattern. The full pattern will be, yeah, pattern. This is going to be basically, let's do again, what was it? Array. Where did we repeat those little there we go. So we can just do literally that to generate our new thingy. So we're gonna repeat not this thing, but this will be our sub pattern. And how many times? It's gonna be the, whoa. What the hell? Sub pattern dot reps. That should be how many times we repeat that, right? So we join it, and after joining it, we can just convert it to an integer. Okay. So this is our whatever pattern. Or this will be potential hit. So now that we have that number, we just need to check if it's within the range of the whole pattern definition, right? So depending on that, we'll be able to save in that database or not. So we don't do any let or whatever, we just do if, and we have the potential hit is larger or equal the pattern definition dot from and a potential. There we go. We have some shortcut if it's less or equal to the 2, because they're both inclusive in this case. Then we're gonna basically do absert, and this way we're gonna do temp, and this will be, how do we construct the thing? Because I don't think we can just do simply, hey, we are pasting in the potential hit here. I mean, it could be a possibility, but in querying, then it will be again a problem. So let's just, I mean, I want it like this, definitely. Set value is potential hit. So the second part is fine, but the first one isn't. And probably having index would help in the future, but we'll be going over everything anyway, so yeah. Let me just check how to create a record ID. So record ID functions. We should check to see if record exists. We can extract stuff, but I want to create it. So not functions, this will be in record IDs. We can create something like this, types of record IDs, blah, blah, blah. We want to create our own text record IDs. Numeric, yep. IDs made with parameters and function calls. There we go. Whether this and that. We can set that. That's great. But there we go. Type record, and that's how we can set it. There we go. So this will be just replace it here. This will be the temp. Yep. And oops. Okay, potential hit. And we set value 2. So the reason why we are setting the value as well instead of just the record is so that I don't know, do we have to set that? I think it will be just easier to query everything like, hey, grab me all the values and that's it. Yeah. So that will be absurd where we always set the record, specific record, and that should be fine. And oops, then we're just gonna finish the if statement. That's the end of our statement here and here and here. Yeah. So if we have this, that will be it, right? Because we iterate over all the possible things. The only thing is that if we have the pattern definition, that's fine. But inside of it, when we go over the sub patterns, wait, sub pattern entry, there we go. We need to basically check if it's null. We want to exclude the ones that are not null. So we can probably do it in a few ways. I'm gonna go with the simplest way, which will be if pattern definition entry is not none, then we're gonna do this stuff, right? Otherwise, we're gonna not do anything. And this should take care of it. So we basically try everything. Okay. And after that, let's just do select value from let's do, I don't know, hits. And therefore we're gonna change it that we're not saving to the template, we're gonna be saving it to hits. Or like hit. There we go. So I'm gonna get rid of all this. This is all just noise now. So I'm gonna select everything and just move it into here. We'll see if we have any syntax problems ahead of time. So I have all this. So now we have pattern, ranges to generate. That's good. Not none. Maybe just this. There we go. When it's not none. Yeah. Will this work? No. I guess I need to wrap it in parentheses, and that's gonna make it a little bit happier. I think so, yeah. Potential hit. Yep. Let's see what happens. This might take a while. Expected range, value of integer, but found string. Oh, that's right. Because these are all not really that. So first of all, pattern definition entry. These are from and to. Oh, that's right. Oh, because these are not numbers, these are just that. I see. Okay, so these are just numbers, right? That means that we need to first convert them to our integers, and therefore our subpattern int is here. So we need to take our subpattern integer and change it into string. And that will kind of do everything. And then at the end, when we're checking for is larger, is smaller, again, we need to change those strings into numbers. It's gonna not be optimized, but probably better. Expect a string, but cannot convert none to a string. Oh. Where are we getting none? That's the question. Which one is none? Because we're guarding here that the entire pattern entry is not none. And in here, we have the pattern entry from. Yep, pattern entry 2. These should be both correct. This is the integer. So where is really the problem? We can just comment this out and see what happens. Okay, all right, so this is good. Nothing happened here, so the problem is not with those. The problem is somewhere in here. We want to convert expected a string, but cannot convert none into a string. So something tells me this might be this first thing. Let's see. Potential hit. Yeah. This is where we're getting a problem. So sub pattern integer might be none. Sub pattern integer. Really? Sub pattern reps? No, pattern definition entry. There we go. Run query. We have no problems now. So if it is within the range, gosh, this completes weirdly fast. What the hell? It knows to do nothing. Correct arguments for function type record. The second argument must be a table name or a string. Wait, a second argument? The second argument must be a table name or a string. What? This doesn't say that. Unless this is the second argument. And we have it as a string. Should this be a string? Record, but cannot convert hit to record. What? Okay, there is something weird going on here. Let me just double check. Type record. We start with hit and we end with that. Do we have anywhere else? We have data types and nothing else about record IDs. Record ranges. Type record. We have this and we have that. Very strange. Unless the second one comes up to be null sometimes. But why does it want? It's as if it's flipped. What if I'm going to do this magical thing? So record hit, but cannot convert 888 into record hit. What the heck? I need to see what's going on. Return this. Expect a string, but cannot convert none into a string. Oh, yeah. At 1 to 3. Okay. Okay. Something's missing here. Type record. What am I going to try that? No, expected 1 or 2 arguments. So now it tries to create a record of 1, 2, 3 as a type, which is wrong. It should be record hit. Expect a record, but cannot convert hit into record. What the heck? What if I'm going to do 1, 2, 3 as record of hit? What if I'm going to do that? Run query. Expect a record hit, but cannot convert 1 to 3 into that. Hey, Mithrodites. I have a very interesting question. How do I create record IDs on the fly? Because nothing seems to be working. The documentation suggests, hey, just do type record, the table, and the value of the record, right? But it ain't work. At least not in my case. I'm trying this, and I'm just gonna say, I don't know, 1 to 3, and it just says incorrect arguments. it's as if the other thing was supposed to be the table name. And then it's like, sorry, I can't convert 123 into a record of user. Yeah. Very, very, very strange. Not sure what's happening here, and I can't find any other documentation. Because that's the record IDs and the whole data types. Other than that, there's nothing database functions for record IDs. Only show how to extract it. Type thing. Oh, that's right. I remember thing. So there is no thing in here. Array float, regex. We have record. So it looks like those docs are kind of confusing. Because the example isn't working. Let's type thing user 123. Now works, thank you. Not sure where to find that then. Whoops, keeps just jumping around. So we'll have our hit to be the potential hit here. Should be a number, not string, so it'll be probably a little bit better now. Let's try it. And that just completed instantly. In how long? In 12 milliseconds. So in our thing, we should have all the hit records created. Okay. All right, we have only 926 hits. Interesting. So thank you for saving the day with your dates. That helps a lot. So potentially we have all the hits, and now we just need to kind of count. I mean, sum things up. So we have group by. We have product region, but I want to not just count, I want to sum. Do we have documentation for that in select? That's my question. Basic usage parameters. Where group by and group all. Group all, that should be it, right? Group all. Use an aggregate function to select unique values. So it'll be okay, so everything will be coming as an array. Therefore, I would be probably able to do just count for group all, right? Okay, this is in 3 alpha. We are not doing that yet, but to speed up count function along with group all to get total number of record. Index can be used. Yep. Standard deviation, variance, that's fun. Okay, so we'll just do regular select count as, I mean, not count. Do we have sum? Just math sum, right? So we go to database functions, math. We'll have sum, hopefully. Let me just double check that we are supposed to add them. What do you get if you add up all of the invalid IDs? All right, there we go. Sum, there we go. All right. And that is literally it. So we're gonna grab all the values and we're just gonna do, actually not here. We need to do it here. Math sum. I guess we don't put anything in here. Let me just double check how it was shown here. Score from person. I guess we need to do value. Yeah. Okay. Value from hit group all. And run it again. 0. Okay, that didn't work. And that's what it says. Okay, I have 2 hands to type again. Type record is the 3.0 name for type thing. Oh, okay, so we updated everything. That's awesome. It just, I guess, needs to be thrown out there that there are 2 variants. You can see all the type functions a bit below in the functions section. I'm curious that the type record path even worked in the first place in 2.x. Yeah, maybe there was some kind of leftover something. Interesting. But now how do I sum those? Do I need... Let's remove value first. Okay, that fixed it. Okay. So this should be the result, right? Let's just put it here because I'm kind of tired of stumbling and not going. That's not the right answer. The answer is too low. Okay. Wow. I might need to give up for now. Are you sure you're using full input data? I think I am. Copy. Now we're gonna do not here. We're gonna do it here. Paste. Yeah, it's exactly same data. It's all good. What if we're gonna do it as, what were the other data types? An array, then we have decimal. It uses big decimal for storing a non-real number of arbitrary precision. So let's use decimal for that, just to be sure if we're gonna get a different number. Add decimal. Okay, gonna do that and try it again. Yeah, it gave me the same result. Okay, so there's some problem with the logic. Let's just grab everything and save it here for now. Bam. So we have it updated, and maybe we can kind of view syntax highlighting here what the problem is. So before we do that, let's just again return pattern definitions and kind of see it again. To kind of see if we're counting something the wrong way. Wait, these are pattern definitions, right? Yeah. So we actually don't want that. We want to be able to, if we go here and here, we have the potential hits and all this fun stuff. So maybe here we can just make it where we do let range is this fun thing. And this will be in range. Could we try to create something here? Hmm. In theory, we can set more than just the value, right? The value is this, but we also can set range is range. We can also set from, let's maybe do something like the overall pattern definition will be pattern definition. Okay. And we're gonna just continue, and this will be pattern def entry. And do we have anything else? Potential hit, that's already the value. And okay, but we're noting that only in case of those. Yeah, we're adding that only for the good ones. But let's try it anyway. And let's see what happens. In our Explorer, we have our hits, and each hit should tell us more. Like hit number 1, literally number 1 was counted? What? Pattern from 1 to 9. Oh. Wait a moment. Pattern definition from 1 to 11. How is 1 allowed? 1 is not repetitive. So we need to kind of exclude the single digits because these are not repetitive. Okay, that's first thing to take care of. But why did it generate them in the first place then? Repetitions 1. How do we get to single repetition? Huh. So that's our first mistake. Then we have something like 2, 2, 2, which is from here to here, which makes sense. Repetitions are correct. All that is fine. 17, 17. Again, that's good. 159, 159. That's correct. So it looks like we're somehow getting repetitions too low. So let's look at our query and see where we actually said that. Prep a list of ranges to draw repetitions to test. Okay. And then we go over each pattern length. Bam, bam, bam. Ranges to generate. And repetitions on the left. So basically, if it's divisible, so let's do actually first. If reps left is larger than 0 and this, there we go. I mean, larger than 1, because we don't want a single repetition. Then the other one is here. So repetitions on the right. And then finally we have normal repetitions if repetitions is larger than 1. Okay, so this should already prevent a lot of this stuff. Although the result didn't change. Or did it? 7 to 6 at the end. Oh, because I have the old entries, right? So let's do explore our hits, right click, clear table, sure, whatever. I'll just remove table. Query and run again. Okay, the value changed. It's a little bit smaller now, but our hint says that we had actually too large of a number, right? Your answer is too low. So really we have more. So we need to look for edge cases where we're not getting large enough entries, whatever. Let's just first look at this. If we have somewhere where we're kind of missing. So we go over each entry, and if the range is from here 2, and we need to do 2 equals. There we go. And I think that's gonna change it. There we go. Those ranges are a little bit different. Okay, remove the table and get back here, run the query, and this should be the answer. If that's gonna be correct, I'll be really, really, really happy. Paste it, submit. No, it's too high. Okay, now it's too high. Okay, so we go definition entry. All right, so it'll be this one. From number 8 to number 9. That's good. And we repeated the number of times we're supposed to. And we just check it. Yeah, that's good. Xconti locks. Not sure what it references to. Oh, yeah. But one is too low. One's too high. Okay, I don't know if Goldilocks. I heard the name Goldilocks, but I never knew what it means. What is Goldilocks? Oh no, I have thinking it's gonna think about it for 3 years. Defining habitable zones. What? Okay. Oh, I didn't grow up in the US or an English speaking country, so we probably didn't have that. I don't know if there's an equivalent in Polish. Concept of just right, finding the middle ground between two extremes. Children's fairy tale of Goldilocks and the Three Bears. Goldilocks and Three Bears. Oh, that's interesting. But the term is... I don't think I remember that, but Three Bears, that sounds like the family of bears. And someone was eating them, but whatever. Eating their food. Okay. Children's book. Not too important for me right now, but... Yep. Didn't know about it. I guess you had tales about gods like Perrin and stuff. Nope. We never learned anything like that. That's far long ago. All right. Yeah, we read Witcher as kids. These are our fairy tales. Just joking. Potential hit is larger or equal to from, and less or equal to. Okay. So that would mean that this is going to be hit, but not out of range, which is the crucial thing. So where are we getting the problematic stuff from? Because duplicates are removed automatically because we're just always setting the same thing here. So that should not be a problem. Repetitions should be all fine. Okay, I am not sure at this very moment. I might be just getting too tired to actually complete it. Wow, I might fail. Hmm. What are the largest numbers here? 10 digits, right? So that'll be bam, bam, bam. It's like 3 billion, maybe not up to, yeah, like 9 billion. How long would it take to just brute force it? Right? But then generate all the repetitions. How does one find all the repetitions? Because it'll be all the repetitions up to 5 digits, which is tons. Because it's harder to check if something is built out of repetitions. It's easier to build them out. Or is it? Because here are so many repetitions, and I tried to build them all out. Only for those ranges. That's what adds the complication here. How hard is it to check a number? I mean, I would need to check all the numbers in between. It's not a... I mean... Okay, these are a few hundreds of thousands for each to check and analyze if it's repetitive or not, whatever. So now, checking all the possible values in between for repetitive stuff is just like one gen nope. For these will be to generate up to 5, which means from 0 to 9, from 10 to 99. That's 100. From 100 to 900. Okay. And from 1000 to this. And lastly, we need to do this to that because we have those large numbers. Yeah. 100,000. So yeah, basically 120,000 or whatever. 100,000 elements to generate. Okay, that's not too bad. We could brute force it. We could absolutely brute force it. But for each number, we would need to check all the ranges. Ugh. Yeah. Yeah. This seems to be the most optimal, but I have somewhere an error. Okay. I'm gonna stop it for now because I'm running out of steam. I guess I'll need to continue tomorrow with fresh mind, try to think about it a little bit harder, and well, we'll be behind, but let's say that to finish it all, we have till the 24th, all right? So sure, we lost some day or whatever, but I'll try every day. We lost tons of time today figuring out that inside of maps, besides this, you have no access for anything outside. And that was a big gotcha. That complicated a lot of code. So yeah, that's that. All right. Thank you for watching. Sorry for not completing. And we'll continue tomorrow. Same time. All right. And thank you for coming in and saving me with the thing. Method rates. It's always helpful. And see you tomorrow.